And this is station 5. Let's take a look at the problems. So here we're estimating volume. So we're going from estimating crowd to estimating volume. And there's some differences here. Approximately 50 tennis balls can fill the inside of a cardboard box with the following dimensions: 6 inches by 13 inches by 13 inches. If my classroom is 11 feet high, 39 feet wide, and 17 feet long, estimate the number of tennis balls required to fill my classroom. And then we're reminded that 1 feet or 1 foot is 12 inches. Well, in this case, we're still setting up proportions so that we can cross multiply and solve, similar to the way we did on estimating crowds. Let's take a look at what we're given. So we're given that about 50 tennis balls, I'm gonna put TB, can fill the inside of a cardboard box with that's 6 inches by 13 by 13. And so that would be a total of 1,014 cubic inches. So because volume is in cubic units, remember area was in square units too. Volume is in cubic units, that's 3. Because we've got a length, a width, and a height, not just area where it's length times width. So that's the difference here. So I'm gonna put inches cubed instead of inches squared. This is volume. Remember, we're estimating volume now. So you wanna switch gears a little bit. But this is still the unit that we're gonna be consistent with. So that means my next ratio should also have the tennis ball value on top and the volume on bottom. Well, we're trying to find the number of tennis balls, so that's our variable. I'm gonna put an X to represent what we don't know yet, what we're trying to figure out. So that's X tennis balls will fit inside. Now this time we're trying to determine approximately how many will fit into a classroom. Now I see I have 11 feet, 39 feet, 17 feet. But with the box that we were given, this is in inches, so we need to get our units to be the same. That means we've got to change this 11 feet into inches, 39 and 17 also. Well, 11 feet is actually, let me write over here. So 11 feet is 132 inches. 39 feet is 468 inches. And 17 feet is 204 inches. So I've converted all those feet for the classroom, the length times the width times the height of the classroom, into inches. Now this is what we're going to multiply. Length times width times height, but in inches. And that total, I'll give you that total because I've already done the work. It's going to be quite a bit. It's going to be 6. Let me write these down. Let's see, 885,504. So it's 69,885,504. That's the cubic inch number that has to go up underneath this ratio. So 69885,504 cubic inches. That's a lot, but it's still the volume of the classroom. And that makes sense. So if a box is 1,014 cubic inches, it makes sense that a classroom, a whole room, would probably be quite much more, right? And then we still got to cross multiply. So let's do that. So we got 1014 times x, which is 1014x. But this is the biggie right here. So we've got to do 50 times this number. And that's going to be, let's see, I've got the numbers 3, 4, 9, 4, 2, 7, 5, 200. All right, so this is 3,494,275,200. All right, now let's divide both sides by the coefficient of x, so we can eliminate that and isolate the variable, get it by itself. So when this cancels to 1, 1 times x is x. And let's put approximately equal, because again, we're estimating and we've got approximate numbers and approximate values. So this will simplify to, let's see, 3, 4, 4, 6, 0, 3, 0, 1, 2, 3, comma, 1, 2, 3, comma. So X is approximately 3,446,030 tennis balls that will fit into the classroom. All right, let's take a look at number 2. This is the last problem of our study guide for AMDM. So this is station 5, number 2. Let's take a look at the problem. A basketball has a diameter of 9.4 inches. How many basketballs will fit inside of a room that's 24 feet wide, 20 feet long, and 10 feet high? As a reminder, you can assume that for random packing space, 190% of the volume of the sphere is needed to pack the spheres, and the volume of the sphere is 4/3 times pi times radius cubed. Okay, so what I've done, pre-work I've done is I've went ahead and, since I have basketball in inches, and we have the room in feet, I went ahead and made the units the same. So I changed all of these feet to inches. Because remember, to find volume, we're talking length times width times height. So we've got 3 dimensions. This is why when we list the units for volume, we do it in cubic units. Whether it's cubic inches, cubic feet, we use the 3 to the 3rd power, because length times width times height. Whereas with area, we only use to the 2nd power because we only have length times width, 2 dimensions. So in this case, I've changed the 24, 20, and 10 feet into their inches, and I went ahead and multiplied them. So the volume of the room is gonna be 8,294,400 cubic inches. Now let's take a look at this basketball. We're told it has a diameter of 9.4 inches, but look at the formula for a sphere. And a sphere, of course, is a rounded a ball. It's 4/3 times pi times the radius cubed. I don't have the radius, I have the diameter. Now how do we find the radius? We actually split the diameter in half. So if I split 9.4 in half, I'll have a radius of 4.7. So I have my radius, and I can actually use the formula. So the first thing we're gonna do is we're gonna go ahead and let's get the volume of the basketball. So let's say the basketball, and we're doing volume of the basketball. We're gonna apply that formula. It is 4/3 times pi times the radius, which is 4.7 cubed. Now, of course, when we do 4/3 times pi times 4.7 cubed, remember the order of operations does apply, because we've got more than one operation. We have an exponent in this problem, and we have multiplication. According to the order, please excuse my dear Aunt Sally. Remember that mnemonic device that we use? Exponent should come first. So I'm gonna do 4.7 to the 3rd power first, and then I'll multiply the rest of these. So this will be 4/3 times pi. And when I do 4.7 to the 3rd power, I've already calculated that. That gives me 103.823. So this value is just that part of the problem, of the formula. Now I still need to do 4/3 times pi times that. And then that total volume for the basketball is gonna be 434.89 cubic inches. So I put inches to the 3rd power. That's how you say cubic inches in your problem. So there's the volume of the basketball. Let's go ahead and get the volume of the room. So now we need volume of the room, which I already calculated earlier. It is 8,294,400, again, cubic inches. All right, so we're almost done, because then we're gonna take the volume of the room and divide it by the volume of the basketball. And that will tell us how many, approximately, how many basketballs will fit in that room. But before I actually do that, I do have to take into account that since these are spheres, and they're not like rectangular shapes that will fit you know, end to end, edge to edge with no space in between. Since we've got spears, we're gonna have some space in between because you can't pack them that tightly. So that's where this packing space comes from. And we assume that since it's random and we're just putting in whatever we can fit in, we're gonna account for 190% of that volume of the spear though, not of the room, of the spear. What that means, so we gotta calculate the packing space. And that's what we're going to divide the room by. So the packing space is equal to 190% of the spear. So it's this percent of the volume of the spear. Now what's the volume of the spear? Right here, 434.89 cubic inches. Notice I didn't apply the 190% to the volume of the room. It's of the sphere, of the ball. And I've already calculated that. So that becomes, now before I actually do the math, I had to convert 190% into a decimal. How do we do that? Well, remember the shortcut method where you move the decimal point 2 places to the left? And the decimal point is always at the back of the number. So if I move it 2 places, 2 places to the left, it will end up between the 1 and the 9. So I'm gonna do 1.9. I can put the 0, I can leave it off. It doesn't change the calculations. Of means multiply. So I'm gonna times that by the volume of the basketball. And then I've calculated that already. It gives me 826.291. All right, so I'm gonna take this, and we are going to divide. So I'm just gonna go ahead and bring that packing space, which is 190% of the sphere, and divide. So 826.291. And that gives us a final answer of, and I've calculated that already, that's 10,038. So I'm going to put approximately, let me change this to approximately 10,038 basketballs will fit inside the room. Okay. All right, so that's the end of the study guide. Good luck on your test. You're gonna do great.